The required working clearance in front of electrical equipment, such as elevator control panels operating at 480 volts, is determined by the National Electrical Code, specifically Article 110.26. This article outlines the necessary clearances to ensure the safety of personnel who may need to inspect, maintain, or repair the equipment while it is energized. The clearance requirements depend on the voltage to ground and the conditions present on the opposite side of the working space. To determine the correct clearance, one must first identify the voltage to ground. In a 480-volt system, the voltage to ground depends on the type of system. If it is a 480 volts grounded Y system, the voltage to ground is 277 volts. If it is a 480 volts delta system and is ungrounded, the voltage to ground is 480 volts. If it is a 480 volts corner grounded delta system, the voltage to ground is 0 for one phase and 480 volts for the other two phases. Assuming a 480 volts grounded Y system with 277 volts to ground is being used for the elevator control panels, we can use Table 110.26a to determine the required working space. Table 110.26a outlines three conditions, which are Condition 1, Condition 2, and Condition 3. Condition 1 exists where there are exposed live parts on one side of the working space and no live or grounded parts on the other side of the working space, or where there are exposed live parts on one side of the working space and insulated parts on the other side of the working space. Condition 2 exists where there are exposed live parts on one side of the working space and grounded parts on the other side of the working space. Condition 3 exists where there are exposed live parts on both sides of the working space. The phrase dead front access only typically means that there are no exposed live parts accessible during normal operation. However, it is crucial to consider the potential for live parts to be exposed during maintenance or repair. Given the presence of elevator control panels, it is likely that at some point technicians will need to access the internal components while the system is at least partially energized for troubleshooting or testing. Therefore, the working clearance must account for this possibility. Now, considering the three conditions previously discussed, we must determine which condition applies to the scenario of elevator control panels with dead front access only. Firstly, Condition 1 applies if the opposite side of the working space has no live or grounded parts, or has insulated parts. Secondly, Condition 2 applies if the opposite side of the working space has grounded parts. Thirdly, Condition 3 applies if the opposite side of the working space has exposed live parts. Given that the elevator machine room is likely to contain grounded metal parts, such as structural supports, conduit, or other equipment enclosures, Condition 2 is the most likely scenario. If the opposite side of the working space consists of a concrete wall, then Condition 1 could be considered. However, it is more common to encounter grounded parts in such a setting. If another panel with exposed live parts sits directly across from the described elevator panel, then Condition 3 would apply. For voltages of 151 volts to 600 volts, Table 110.26a specifies the following minimum cleared distances for the three conditions. Firstly, Condition 1 requires a minimum clear distance of 3 feet. Secondly, Condition 2 requires a minimum clear distance of 3.5 feet. Thirdly, Condition 3 requires a minimum clear distance of 4 feet. However, there is an exception to these rules that could change the working clearance. If the equipment is only operating at 150 volts or less to ground and the entire enclosure can be de-energized using a main disconnect, the working clearance is permitted to be reduced to a minimum of 3 feet. However, elevator control panels operating at 480 volts would not meet this criteria. Given that the voltage to ground can be assumed to be 277 volts under a 480 volts grounded Y system, or even up to 480 volts in other types of 480 volt systems, and considering the likely presence of grounded parts on the opposite side of the working space, the minimum required working clearance in front of the elevator control panels is generally 3.5 feet per Condition 2 of Table 110.26a. However, it is important to note that local codes or regulations may have additional requirements or more stringent interpretations. It is always best to consult with the local authority having jurisdiction to ensure compliance with all applicable codes. Additionally, it is important to maintain this required clearance at all times. The working space should not be used for storage or other purposes that could obstruct access to the equipment. Proper housekeeping and maintenance practices are essential to ensure the safety of personnel working on or near electrical equipment. Furthermore, the working space should be adequately illuminated to allow for safe and effective work. Lighting should be positioned to minimize glare and shadows. Also, appropriate safety signage should be posted to warn personnel of potential electrical hazards. Signage should include warnings about the voltage levels and the need to maintain safe working distances. Any unqualified person should be kept at a safe distance from the electrical equipment. Only qualified personnel who have been trained and authorized to work on electrical equipment should be allowed within the working space. The use of personal protective equipment, or PPE, is also essential for electrical safety. PPE may include items such as safety glasses, gloves, and arc-rated clothing. The specific type of PPE required will depend on the task being performed and the potential hazards involved. The National Electrical Code also addresses the height of the working space in Article 110.26a3. The working space must be clear and extend from the grade, floor, or platform to the height specified in 110.26a3. In general, the working space must be at least 6.5 feet high or the height of the equipment, whichever is greater. This ensures that personnel have adequate headroom to work safely. The width of the working space is also important. Article 110.26 specifies that the width of the working space in front of the electrical equipment must be at least 30 inches or the width of the equipment, whichever is greater. This provides adequate space for personnel to move around and work on the equipment. In summary, determining the correct working clearance for elevator control panels operating at 480 volts requires careful consideration of the National Electrical Code, specifically Article 110.26 and Table 110.26a. While a clearance of 3.5 feet is generally required under Condition 2 for voltages between 151 volts and 600 volts, it is important to assess the specific conditions of the installation and consult with local authorities to ensure compliance with all applicable codes and regulations. Proper maintenance, housekeeping, lighting, signage, and the use of PPE are also essential for ensuring the safety of personnel working on or near electrical equipment. Also, it's important to remember that the minimum working clearances provided in the NEC are just that, minimums. In some cases, it may be necessary to provide additional clearance to ensure the safety of personnel or to accommodate specific equipment configurations. Factors such as the complexity of the equipment, the frequency of maintenance, and the skill level of the personnel performing the work should all be considered when determining the appropriate working clearance. When in doubt, it is always best to err on the side of caution and provide more clearance than the minimum required by the NEC. This will help to ensure that personnel have adequate space to work safely and effectively. Also, always verify that any changes or modifications to the electrical system are inspected and approved by the local authority having jurisdiction to ensure compliance with all applicable codes and regulations. Electrical safety is of paramount importance, and it is the responsibility of all stakeholders, including designers, installers, and maintenance personnel, to ensure that electrical systems are installed and maintained in a safe and compliant manner. By following the guidelines and requirements of the NEC and by implementing appropriate safety practices, it is possible to minimize the risk of electrical accidents and injuries. In addition to the working clearances, the NEC also addresses other important aspects of electrical safety, such as grounding, overcurrent protection, and wiring methods. It is essential to have a thorough understanding of these requirements in order to ensure the safety of electrical systems. It is important to distinguish between working clearance and dedicated equipment space. Working clearance refers to the space required in front of electrical equipment to allow for safe access and maintenance, as discussed earlier. Dedicated equipment space, on the other hand, refers to the space above and below electrical equipment that is reserved for the exclusive use of the equipment. This space is intended to protect the equipment from damage and to ensure that it can be properly ventilated and cooled. The requirements for dedicated equipment space are outlined in Article 110.26c of the NEC. In general, the space above electrical equipment must be kept clear of obstructions that could interfere with the equipment's operation or maintenance. Similarly, the space below electrical equipment must be kept clear of obstructions that could damage the equipment or create a safety hazard. Common obstructions to avoid in dedicated equipment space include piping, ductwork, and storage. It's also important to consider the potential for future expansion when determining the dedicated equipment space. If there is a possibility that additional equipment will be installed in the future, it is wise to provide additional space to accommodate the new equipment. This will help to avoid the need for costly and disruptive modifications later on. The location of electrical equipment should also be carefully considered. Equipment should be located in a dry, well-ventilated area that is protected from physical damage. It should also be located in an area that is easily accessible for maintenance and repair. Equipment should not be located in areas where it could be exposed to corrosive substances or excessive heat. In addition, electrical equipment should be located away from areas where it could be a safety hazard to personnel. For example, equipment should not be located near walkways or other areas where people are likely to be walking. By following these guidelines, it is possible to create a safe and efficient electrical system that meets the needs of the facility. In addition to the NEC, there may be other applicable codes and standards that must be followed when installing and maintaining electrical equipment. These codes and standards may be specific to the type of equipment being installed or to the location where the equipment is being installed. It is important to be aware of all applicable codes and standards and to ensure that the electrical system is in compliance with these requirements. Examples of other codes and standards that may be applicable include the International Building Code, the International Mechanical Code, and the National Fire Protection Association standards. It is also important to note that the requirements for electrical safety may vary depending on the jurisdiction. Some jurisdictions may have more stringent requirements than others. It is important to check with the local authority having jurisdiction to determine the specific requirements that apply in a given area.